In this video, we're going to learn about the refrigerant pressure readings on both the low pressure and high pressure sides of an air conditioning system. Understanding how refrigerant pressure behaves on each side of the AC is very important. It helps you correctly identify if the system has the right refrigerant charge and makes refrigerant recovery much easier to understand. When the air conditioner is turned off, the refrigerant pressure stays the same on both the low and high sides. For example, when the ambient temperature is around 24 degrees Celsius, an R410A system that's switched off will show a pressure of about 210 to 215 psi on both sides. As the surrounding temperature rises, the refrigerant pressure also increases. At 27 degrees Celsius, the pressure typically goes up to around 236 to 240 psi. Once the unit starts running, the suction line pressure begins to drop. While the discharge line pressure climbs higher, the pipe with the larger diameter is known as the suction line, and the pipe with the smaller diameter is the discharge line. When the AC operates, the compressor pulls refrigerant through the suction line, which causes the pressure there to decrease. Meanwhile, the compressor pushes refrigerant into the discharge line, and this action raises the pressure on that side. During operation at around 24 degrees Celsius, the refrigerant pressure in the suction line usually ranges from 120 to 125 psi. The refrigerant flowing through the suction line comes from the evaporator inside the indoor unit. On the other hand, the refrigerant found in the discharge line comes from the condenser located in the outdoor unit. At temperatures between 35 degrees Celsius and 36 degrees Celsius, the pressure in the discharge line can reach up to 600 to 605 psi. Keep in mind that refrigerant pressure always changes depending on the temperature. I hope this explanation helped you clearly understand how refrigerant pressure behaves in an AC system. If you have any questions, feel free to ask in the comment section. And don't forget to subscribe to our channel, Intact Knowledge. Thank you for watching.